Okay, in this video, we are going to be discussing the properties of the square root function and calculating them. If we look at the graph, notice how the square root of x is never negative for y if I look at that plot. That is our square root function. So it's never negative for x, and it's never negative for y. It can only be equal to 0 or greater than that. Logical, right? No matter what we put in to x, it's always going to become squared, right? We're always squaring that quantity. The square of any quantity is always going to give you a positive number. So negative 4 squared is positive 16, negative 1 squared is positive 1, and so on. It can go on forever. So, and that's why we're just looking at 49x squared. I squared both sides here of this. So what I did, you can say Chit is the independent variable, and he's equal to 49x squared. It doesn't matter what you put. You can put your name. We could say Linda, right? Whatever we want to put. We could say L. So this is your output, right? This is your dependent variable. Whatever you plug in for x, you would expect an output for your dependent variable. It depends on x, what you plug in, and the function, right? It gives you a behavior. That being, if you look at the graph, this. Now this graph is not the same graph, it's just the graph of square root of x, but I'm using it as kind of a reference so you can see. So don't think we're going to get the same values, it's just so you can see that we're never negative down here and we're never this over here. And the reason why I use the square, since we're never negative over here, I want to be able to see y. So I'm using y squared. But let's go back a little bit. We're going to start with the fact that y happens to be equal to 49 x squared. Now we're going to simplify this here in a minute, right? So what I did in order to make sense out of this is squared both sides of this equation. Make sure you invoke your parentheses anytime you do this so you're not losing information. That's important. So we get to this equation that I was promising. We have y squared is equal to 49x squared. Don't really think about the y squared too much. We're just interested in what happens to this x here. We're trying to show that x cannot be negative. And if it is, then we're always going to get a positive quantity back. We're never going to get a negative quantity back for this. So that's where I start. I've got this 49x squared over here, right? So we're just going to analyze really the right side of this to see if we get any sort of positive representation, whether it's John C. Riley, sorry, Y or not. So let's go ahead and do that. Don't put your hand in the toaster, Riley. You're never going to get a negative value for the expression on the right hand side, which means y is never going to be negative. So if you plug negative 4 into this thing and square it, you get positive 16, which means 49 times positive 16 is 784. Nothing came out negative. That came out as a positive 16 times your coefficient. If you do it for negative 1, square that, that's a positive 1. 49 times 1, 49. 0, anything times 0 or squared is going to give you 0. Again, if we do 1, notice how we get that 49 back again, right? Something having to do with the squares, right? Don't think too hard on that. Now, putting a positive 4, we get the same thing that we started with negative 4. What does this tell us? This tells us that we're never going to get a negative value for y. So if we look to the graph that I have displayed to the right-hand corner, now it's not going to be the same numbers, but that graph is always going to have that behavior no matter what numbers you use. If it's a square root function of x, no matter what coefficient you have in front, that simply just stretches your graph. We don't care about that. I mean, yeah, if you want to get the answer right and crunch the numbers, sure. But the idea here is that we want to know the behavior. We want to know what's going on. We want to know how to model these. So if you look at your graph over here, we see that y is never negative for the function square root of x. So I've proven using a table of values here. If you want me to do 100 more, we can. But I think I've concretely proven here that this is never going to be negative. So what do we do with the negative x? Well, if it never gives us a negative value for y, we just leave that out. Always positive. Your output's always going to be positive. So in order to demonstrate that y is never negative, we put a positive here, right? That's going to tell us that No matter what x, yeah, humor me, if it had been negative, we're never going to get that negative value for y. Now I need to show the contradiction if we use the math. Now we're going to throw that contradiction out from what we just discussed, that y can never be negative, and that's why we're using the positive symbol here on the square root function. So to that end, I'm just going to use some convenient values like -1, 0, and 1. Now I'm showing you the contradiction and why we simply logically throw that out. We're not really using, we already did the algebra, and now we're just logically throwing out because now we know it can't be negative. And from what we can see in this problem, the square root of 49, let's go ahead and do the plus or minus. That's going to leave us the radical frees up the square inside. We're going to say we got that plus or minus here, and that's going to give us 7, right? So plus or minus 7, but we just investigated the fact that we cannot have a negative value for y because we're always positive, right? No matter how we slice this, we're always going to be positive. So in order to fix this contradiction, we simply logically throw out that negative value. What that means is in a lot of textbooks, you'll see this absolute value for x. That just means that x has to be, again, that means that x has to be greater than or equal to 0, no matter what. That's exactly what that means here. You're not really solving an absolute value quantity. You're just kind of proving that, hey, throwing out this contradiction here that, and from the table above, we know that x has to be greater than or equal to 0 because it doesn't give us any reasonable or logical output for y. Uh, that's it, right? So no matter what happens when anything squared for x, you're never going to get that for y from all these pieces involved with the square root function y equals square root of x, or in this case, what we had above. Now, to finish this problem, this is what we had. Now, from what we know, this has to be positive. So all we do is we simplify the 49 inside. We need to break it up using our properties of radicals. And the square root of 49 happens to just be 7. And the square root of x squared happens to be x. A lot of textbooks will write the absolute value there and ask you why. We have just shown why that is. You can really just write this. If it asks you to explain why, well, you can do your table or just demonstrate the graph. But this is it. And you might put for any x greater than or equal to 0 to be a little more specific. But that's what those fancy little bars mean over here, that you really don't have to write out if you understand this logic. We simply do this, and this is often helpful when we get to piecewise functions. Here, come in! Let me in! Come in!